All right. Hello, sixth graders. I'm so glad that I could have a video for you today. Technical difficulties resolved. So we're going to start. First, you should have your homework with you. So please make sure you have your homework on your desk from yesterday. You're due now, so we can go over it in the packet for today. So you have 15 seconds. Make sure you have the homework due now and today's packet on your desk in 15, 14, 13, 12, 11, moving quickly and efficiently, 10, 9, 8, 7, looks like we're almost there, 5, 4, 3, 2, 1. Awesome. Okay, so starting with the do now, let's go over that. So talking about discovery of electricity, as you guys found out yesterday, electricity is our new mini unit, 5.5. And looking at these questions, what does the picture on the right show us? So the picture is the caption of Benjamin Franklin, proved that lightning is a form of electricity. So for this picture, what did it show us and why do you think the author included that picture? Turn, tell your neighbor your answer, go. I'm sure I'm hearing some fabulous answers right now. 15 more seconds. And I should have all eyes up here tracking me. Awesome. So what you should have is that the picture on the right shows Benjamin Franklin getting almost electrocuted by lightning. And why do you think the author included the picture? One reason I think the author included the picture is that's a story a lot of people have heard, so it helps us bring up what we already know about science and include that. Another is that it supports what he's talking about in the text, so that also helps us understand. Second question is, why do we call the unit of electricity volts? So there is one scientist who we named volts after. That person is Alessandro Volta, so that should be your answer for number 2. We named it after the scientist who is the first person to create a battery, which we have now, ours look much different than that. That is the basis of the battery we use today. So for to do now, mark that out of 2. 2 out of 2 is 100. 1 out of 2 is 50. 0 out of 2 is 0. And then please put your do now away. 10, 9, away, 8, 7, 6, just are clear of everything except homework and packet in 5, 4, 3, looking at just 2 things, 2, and 1. Excellent. Look at all of these wonderful scholars tracking me with their beautiful smiling faces on this Tuesday. All right, there we go. So today's question, very similar to yesterday's, is how does electricity move? And how can I use my observation skills to gather information? So yesterday you looked at some pictures that showed circuits and had to make some observations. You also read for homework and you thought about what do you actually know already about electricity? What do you think of when you hear that word? There's a lot of things we use when we talk about electricity. We can talk about a lot of different things. So where do you stand and what do you think of in your brain? So to get us started today, I want you to do the engage your brain question at the top of your page. So everyone's fingers on the box. Make sure everyone's where you're supposed to be. Double check your neighbor. Question says, what information do you remember from yesterday? Think about the diagrams and your homework. So take 1 minute or minute and a half. I'll give you a minute and a half to write as much as you can in the box. Your minute and a half starts now. So I should see everyone already writing down what they remember, thinking about the pictures they looked at, the homework that they read about, different circuits. I can't wait to see these awesome answers tomorrow when I come back. About 1 more minute to finish up your ideas. Writing the whole time, as much as you can think about. You can even think about what you would have added to those pictures if you already write out of your ideas. right, eyes back up here. 2, 1, and 0. So, yesterday you thought about a lot of different things. They should be on your paper right now. Everyone's brain should be ready to go. Now, since I am not here, it's really important that you understand this on your own. And one thing that scientists, in particular scientists when they're in college, do is they read text multiple times to make sure they really truly understand all the ideas in it. So that's what we're going to do today, is we're going to look at the same text you looked at for homework, and we're going to break it down with a partner. And so everyone right now, flip to your homework, the first reading page where it says, what are simple circuits? Everyone's looking at the page that says, what are simple circuits? 5, 4, double check your partner. 3, 2, 1. Excellent. So we're going to use, we did this once before. We called it the clarifying bookmark and used it after each paragraph. I'm going to read the directions. I'll show you what you're going to do, and then it's your turn to actually go through this and talk about each piece one by one. So the more you get out of this today, the easier tomorrow will be when we have to actually build circuits and make sure they work. So make sure we're going very slowly and understanding everything that we can. So directions under break it down. Everyone's fingers there. Okay. First thing, you're going to reread the homework text with a partner using the clarifying bookmark, which is this right here at the bottom. One person reads a paragraph. At the end of the paragraph, that person, the reader, uses the bookmark. I don't really know why it's called the bookmark, just go with it, to respond to the text. Then the listener, the other person, is going to respond to that statement. Then you switch for the next paragraph, and you repeat until you're done with all 3 pages of the text. I'm going the wrong way. But there you go, 3 pages of the text. So for example, I'm going to model this with my fabulous twin sister on this side. And if I'm the reader first, I read my first paragraph that says parts of a circuit. Electric charges move in a circuit. Notice I'm reading out loud, and my partner is going to follow along to make sure that she understands as well. So, electric charges move in a circuit. A circuit is a looped path. A simple circuit has an energy source and at least one conductor. I love that I see people following along their text as well, making sure they understand. It can also have a switch. A switch opens and closes a gap in the conductor. It turns the circuit on or off. Circuits often have resistors too. It's the end of my paragraph. So I come over and I look at my chart. I can do one of 3 things. I can summarize my understanding so far, use my prior knowledge to help me understand, or use a related text, pictures, table, or graphs to help me understand unclear ideas. I'm going to use a picture to help me understand. So then I can say, if we look at this graphic, it shows a circle, a looped path, and it has a switch here, just like it said, that can turn it on or off. And it also talked about a conductor, which it says over here, and a resistor. It doesn't tell me quite what they are, so when I like that when I look at the picture, I get extra information to help me understand. Now, my friend comes over here. Her turn. Hi. So I'm going to respond, and I'm going to say, I agree with you that the picture is really helpful. I'm really bad at accents, sorry. And that I like that I can add information about what a resistor is that I didn't understand the first time. Okay. Now we're going to switch and repeat and go all the way through. So you have, with your partner, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 paragraphs in this text. You and your partner have, let's say, 10 minutes then to read the paragraph, respond to the response, and switch. Ready? I don't think you're ready. Are you ready? Set. 10 minutes starts now. Go. So the first person right now should be reading out loud the first paragraph. Even though I just did it, you have to do it too. Getting situated quickly. Some awesome connections. Keep it up. for being super persevering right now. Keep it up. Make sure both partners are responding to each paragraph. Make sure that you're answering each question and responding to the best of your ability to understand everything you can about circuits. If you finish early, you're working on the above and beyond at the bottom. One good sign of really understanding something is that you can teach it to someone else. So that's how we're using on the bottom. How would you teach someone else about circuits? I can just see everyone earning these persevering points by working super hard and being very focused throughout this entire time. I'm really excited to hear about all your teaching ideas for how you would explain circuits. So you're working on your above and beyond as soon as you're done talking with your partner. I can't wait to come back tomorrow and hear about how hard you worked for the whole time, making sure everyone understood every single piece of information in the text. If there's something you have a question about, write it down on the side so you can ask me tomorrow or ask someone else at your table when we're done. So that was your 10 minutes. Hopefully you're done by now. If not, we're just gonna move on because I can't change the time in a video. All right, so for that, I'm hoping that you can now tell me what a circuit is. So my first question to you then is, what is a circuit? Right now, turn and tell your table, so everyone's talking together, because you just worked with a partner, share out, what is a circuit? Go. Make sure everyone shares and everyone agrees. Eyes are back up here. What is a circuit? A circuit is a loop through which electricity can flow. So we should have an understanding of a circuit is it's like a circle. Circuit is like a circle. and that electricity can flow through. And there are certain parts that have to be there for a circuit. So right now, think about it, and at the bottom of your paper, write down, from what you read, what are the parts of a circuit that you think need to be there for it to work? I have 4. 3 that have to be there, 1 that's maybe there. So what are 4 things that have to be part of a circuit? Individually, write down, what do you think 4 things that have to be part of a circuit are at the blank space in the bottom? Go. See everybody scribbling furiously, writing their answers down? 10 more seconds, get your ideas out. 5, 4, 3, 2, and 1. Ready? Turn, look at your partner. Look them in the eye. Tell them what you got. Go. Oh, I should be hearing some marvelous answers. Sharing everything that we've learned. And eyes are back up here at the board looking at me. 2, 1, and 0. All eyes need to be tracking. Thank you. So what I had for my answer, and what you should have come to with your partner, is that a circuit needs to have a battery. So it needs to have some kind of power source to start it. It needs to have a wire for it to go through. And it needs to have a resistor or something to power. So it needs to have a light bulb, something, or like your phone charger, something that is going to actually put the electricity through so we can see it. The 4th thing I thought of was a switch. It can have an on or off switch, so the circuit is either always going, or if you turn it off and you open it and it's not connected anymore, so if you disconnect it, then it stops the circuit, stops the circle, and it will shut off. So if you turn your page, that's what a basic circuit is. Let's talk about the 2 different types of circuits. There are 2 different types of circuits. One is a series circuit, and the other is a parallel circuit. Both of these things are nouns. So for part of speech in both columns, please write noun. Everyone should have noun written in both columns. Both of these things are things, therefore they are a noun. You're talking about a circuit, it is a tangible thing. You can hold it, you can touch it. Not always a good idea, so please be careful. But therefore it is a noun, it is a thing. Let's start with a series circuit. A series circuit is, I'm going to say the definition 3 times. So listen first and you can write the second 2. A circuit with 1 path or 1 loop. A series circuit is a circuit with 1 path or 1 loop. 3rd time. A series circuit is a circuit with 1 path or 1 loop. It can have multiple resistors, so it can have multiple light bulbs on it. But if one goes out, they all go out. So in a series circuit, if you can have multiple things on it, but if one breaks, they all break. So think about like the lights people hang at Christmas, like the strings of lights. If one of that whole string goes out, nothing will light up. That's a series circuit, right? Because one thing broke, but the rest of it went out too. So it's series circuit. It has 1 loop, and if one thing goes out, whole thing goes out. I get almost like the World Series. If you lose enough games, you're just out in general, right? So a series circuit, 1 out, all out. So take the next 30 seconds to draw yourself a picture of a series circuit. So you can see here's my lovely, beautiful, super artistic example. Or you can use the ones in your text of a simple circuit. That is just the 1 loop circuit where you can see that there are multiple resistors, so multiple light bulbs powering it. Your 30 seconds to draw has already started, so I hope you're going fast. Go. Remember, it doesn't have to be super fancy, doesn't have to be super artistic, just has to be correct. So it has to have just 1 loop, and it has to have a battery. Make sure it has a battery to make it a circuit. Pencils down. 5, 4, 3, 2, and 1. All right, so eyes are up here, pencils are down. We are looking super professional, fabulous, sitting up straight and tall because we are awesome scientists. Yes, we are. And because we're awesome scientists, Miss Duggan added an extra box. Oops. So we're just going to skip other forms of the word because a series circuit is just a series circuit. And we're going to skip to parallel circuit. You already wrote it's a noun. Now here's the definition. I'm going to say it again 3 times. Listen first, then you can write. A circuit with multiple paths is a parallel circuit. Sorry, reverse. Let me say that again. A parallel circuit is a circuit with multiple paths. It looks like it has parallel lines. It has multiple paths going through, so it looks like it has parallel lines. A parallel circuit is a circuit with multiple paths, more than one. It looks like it has parallel lines, so lines that do not intersect. A parallel circuit is a circuit that has multiple paths, so it has multiple wires branching out, and it looks like it has parallel lines. That's where it gets its name. And why we use a parallel circuit is that because it has these multiple lines, so you can see it has multiple different branches and different light bulbs on them. If this light bulb over here goes out, these two stay lit because there's still a complete circle of energy happening between them and the battery. So the electricity can go all the way through. Whereas over here, if this one goes out, now the circle is stopped and it can't keep going. Over here, if you stop the first one, even here it can keep going. So the whole thing, one goes out, the rest of them are fine. So think about like with in the lights, if one light bulb goes out, the other ones stay lit, right? So one light bulb goes out, the rest stay lit. That's a parallel circuit. Parallel means that there's more than one path, so that more than one thing can be powered by it. Take 30 seconds to draw yourself a parallel circuit. You can either copy my beautiful, beautiful drawing, draw your own, or you can use the example in your text, which again, look, it looks like it has parallel lines. Parallel circuit. 30 seconds, go. Look at those drawings. It's gonna blow me out of the water. Like someone started my timer when I wasn't here. All right, eyes up here, 2, 1, and 0. Everyone's tracking. We are looking fabulously wonderful. Love it. So again, we're gonna skip the other forms of the word box because I was just being silly. You don't need that. There is a parallel circuit, and it is a parallel circuit. That's all it is. And you're going to on your own first. You'll have a chance to talk about it. Right now, I want to know what your ideas are. Answer the 2 questions at the, or not answer the question, sorry. Finish the 2 sentences at the bottom. So it says a series circuit is similar to a parallel circuit because. Finish that. And then a series circuit is different from a parallel circuit because. I'm going to give you, there's 2 sentences, 2 minutes to finish it. There's a lot of lines. There's a lot of space. Use it. I want a lot of ideas. 2 minutes. Go. So I see a lot of people already writing down their ideas. Awesome. So make sure everyone is being persevering and professional, using their time wisely. Make sure you answer both questions. For the bottom one, I thought of 2 ways they're different. See if you can come up with both. About 30 more seconds, so make sure you have all your ideas on the paper. If you're done, see what you can add. See if there's anything you think someone might disagree with. All right, so eyes are up here. With your partner, right now, share your answers. How did you say that they were similar, and how did you say that they were different? Each person needs to say both of their sentences. So each person says both their sentences, go. So I'm sure I'm hearing some wonderful ideas about how they're similar and different. Make sure both people share. So your eyes are back up here. Now my answers for this, and yours could have more. So if you do have something different and you're not sure about it, you can ask me tomorrow or talk to your neighbor at an appropriate time. So I said that a series circuit was similar to a parallel circuit because both circuits allowed electricity to flow through them in a complete circle. Both circuits included a battery, a wire, and a resistor. I'll say that one more time. I said that a series circuit is similar to a parallel circuit because both allow electricity to flow through them in a loop or a circle. They both also have a battery, wires, and a resistor to make it a full circuit. I said that a series circuit is different from a parallel circuit because in a series circuit there is one loop and one path for the electricity. In a parallel circuit, there is more than one loop and more than one path. Therefore, in a series circuit, if one light goes out, they all go out. In a parallel circuit, if one goes out, the other ones stay on. So what I said is a series circuit is different from a parallel circuit because a series circuit has one loop and a parallel circuit has more than one. 2, 3, more than one. In a series circuit, if one light bulb goes out, they all go out. Think Christmas lights. In a parallel circuit, if one light goes out, the other ones are fine. Think like the lights in your house. So check your answers right now. If there's anything you need to add it real quick. And then we're going to flip the page to the one that says draw it at the top. Let's try and get there in the next 4, 3, 2, 1. Awesome. So the directions are pretty clear. Draw it, a series circuit. Draw a series circuit on your paper. Go. Doesn't have to be beautiful, but it has to be there. If you have plenty of room, make it nice and big. Turn and look at your partner's picture. Are they on the right track? How many loops do they have? It is a series circuit. How many should they have? How many do you have? Double check that you have a battery, wire to draw your circuit, and a resistor. Let's make it super complicated and add 2 resistors. Take 10 more seconds to finish drawing. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So you should have a drawing that looks something like this. It has a battery, it has a wire in one path, and it has more than one light bulb or resistor. Check that yours looks like this. If not, fix it. And now we're going to play a little game called What If. So this is your circuit. Now imagine, what if the wires were cut right next to the battery? So if I cut the wires right next to the battery, what's going to happen? Turn and tell your neighbor. You and your partner have 30 seconds to figure out what's going to happen to this circuit if I cut the wires. Go. Make sure you write your answer down in a high quality complete sentence. What if you cut the wires next to the battery? The correct answer is that everything will go out. There would not be a circuit anymore. There would not be a flow of electricity. Nothing would work. So both light bulbs would go out if you cut the wire next to the battery. Answer the next 2. So 2, what would happen if the battery died? Talk to your partner, write it down. And what would happen if 1 light bulb went out? There's 2 questions. You and your partner have 2 minutes to answer them out loud and write it down. 2 minutes, go. Think about what makes it a series circuit and what the role of each thing in it is. Make sure you write down your answers as well as talking about them. Helps you remember. Make sure you finish numbers 2 and 3. If you finish both those, make up your own. What if? What if you fill it in? Awesome. So the answers that you and your partner should have come up with. So these are the right answers, and it's really important you understand this because you do have an exit ticket at the end today. Is that if the battery died, the whole thing would stop. You know this. When the battery on your phone dies, or when the battery on my iPad dies, the whole thing dies. None of it works. So if the battery dies, it stops. If one light bulb went out, so if this light bulb went out, what would happen to this one? Because it is a series circuit and there is just one path, if I stop the path here, this one goes out too. So if you stop the path here, electricity can't make a circle, this one's not going to light up. So if one light bulb went out, they all went out. Double check your work, then flip to the back where it says draw it, parallel circuit. Take 30 seconds to draw yourself a beautiful parallel circuit. Go. Ten more seconds. Doesn't have to be beautiful, just has to exist. Draw that beautiful picture. Mine is super lovely. 10, 9, pencils down, 8, 7, 6, 5, 4, 3, 2, and 1. Awesome. So yours should look something like this, where it has a battery, multiple paths, and multiple, excuse me, I'm sorry, resistors. Make sure yours looks like this. And we're going to play what if. This time I want you to do it on your own. By yourself, answer these 3 questions. We're running out of time, so it does not have to be a complete sentence. Just write down the answer to each of these really quick. By quick, I mean like 1 minute because we're running out of time. Go. Answering each question. What if the wires next to the battery were cut? What if the battery died? And what if one light bulb went out? For a parallel circuit. I think I see some people using a really good strategy of putting their finger on the picture to see what would happen. Very, very achieving. Very mindful of your strategies. Okay, so eyes are up here, and I know it was not a lot of time, so it's okay if you're not done. For number 1, if the wires next to the battery were cut, so if I cut the wires where my finger is, what's going to happen to all the lights? The correct answer is none of them will turn on. If you cut the wire here, you do not have a circle. You do not have a circuit, it will not work. So if you cut the wire next to the battery, none of them will turn on. For number 2, if the battery dies, it's the same as a series circuit. If you don't have a power source, none of them will work. If the battery dies, it won't work. None of them will work. If one light bulb goes out, so if this guy goes out right here, what's going to happen to these two? They'll still work. There is still a circuit here going through. There's still a circuit going to the far one. Only the middle one goes out. Check your answers. And when you're done checking your answers, what we're going to do, ready, is you're going to hold your paper, the 2 papers we just did in class, hold them in your right hand, and the one that says homework and the paper behind it, hold those in your left hand and hold them up like this. Hold them up above your head. Double check that your partner has the split in the right place. So you should be looking at the back of their parallel picture and the front of their homework. Hold them up, and on the count of 3, you're going to tear them apart. Not till at 3. 1, 2, 3. Separate. This one, when I say go, I'll play the song, so listen to it. This one, your notes from today, go in your folder. We're using the same one as energy. It goes in the middle. Circuits part 2 goes in the middle. You have your other homework out. This goes in the middle too. Circuits part 1, circuits part 2, into the folder. Your homework. It says homework on it. Same as yesterday. The directions are very clear. Read and mark and answer the questions. The more you understand this, the easier tomorrow will be when you have to build a circuit. This goes in your folder. You have your exit ticket with you. As soon as you're packed up, you may start. You have until the end of the song to be packed up with homework in your folder, written down, it's on the board, notes in your folder, exit ticket out, and working on it. Go. There's not a ton of time, so as soon as you're packed up, get started on your exit ticket. Moving super efficiently and professionally. Make sure everything's cleaned up. Check the floor around you. It was pretty messy when I came in here. And everyone's desk should be cleared. You have the rest of class, so that's about 3 minutes. There's 4 questions, the bottom one's above and beyond, to finish your exit ticket. Thank you for doing such a fabulous job today. When you're done, you're going to hand them in so I can check them, and have a wonderful rest of your day. Show me what you learned. I will see you tomorrow. Thank you.